So with exponential growth and decay, there are a lot of applications. We briefly mentioned some of those last week when we were talking about different growth models, such as population. There's with stocks, I think, was another one that you guys mentioned. So we're going to use these models of growth and decay to make predictions, and then we're going to use a new formula called the compound interest formula. So the growth model and the decay model are both very simple. The growth is y equals a times 1 plus r to the power of t, whereas the decay is a times 1 minus r to the power of t. So in both models, you have the same variables. Okay, your y is the final amount. So that can be money, it can be population. There's a variety of different factors. Our a is the initial value, which is the same when we were talking about that last week. And then r is the rate expressed as a decimal. So the rate is normally given as a percentage, but every percent you can rewrite as a decimal. And then t is going to be the time, often in years. And then we have what is called a growth factor. And the growth factor is 1 plus the rate. Do you guys know as a percent what 1 represents? 100%. Yep. So that means you have everything you had before plus that rate of growth, whereas the decay factor is 1 minus r. The 1 is still 100%, but now you're subtracting whatever your rate is. And we're going to use that to help us in example 1. So it says Clara invests $5,000 in an account that pays 6.25% interest per year. Write and graph a function that models the account, then determine how many years it will take her investment to be worth $10,000. Okay, so there's a lot of things happening in here. The first thing we want to do is identify whether it's growth or decay. So if she's investing money, right, she's investing $5,000 and they're paying interest, is that going to be growth or decay? It's going to be growth. Okay, so we're going to follow our growth model. So this one is going to be a growth model, which means we're going to use 1 plus r to the power of t. So the initial value is how much she invests. So the a value is 5,000. The percent is 6.25. So when you're turning a percent into a decimal, there are many ways you can do that. Is there a certain way that you guys remember how to turn a percent into a decimal? Okay. Yeah, so you would divide by 100, which is just moving the decimal 2 places to the left. So if you go 1, 2, the decimal becomes 0.0625. So you can always take your decimal and move it 2 places to the left, and then you put that 0 in as your placeholder when you need to. Okay, so your model is going to be y equals 5,000. And then the 1 plus the rate, we're just going to do that automatically instead of 2 steps. So 1 plus 0.0625 is 1.0625, and that is to the power of t. So that is what we would call our growth model. Now, it says to write and graph a function. So if we're writing and graphing the function, we already did the writing part. We are going to graph by making a table, and this will be something that you can use your graphing calculator for. Now, when you're doing some of these story problems, if they don't tell you how many years to graph it over, because I know at least one on your homework does tell you, oh, graph this over a period of 5 years. If it was graphing over a period of 5 years, then you would plug in axes 0, 1, 2, 3, 4, 5. But a lot of times, you're going to have to go a lot further than that so you can see what's happening over time. Okay, so what you're going to do is plug this in to your y equals. Okay, so you have 5,000, 1.0625, and then this is to the power of, and you're just going to use your x. My window actually already is big, but yes, we are going to have to. So when I'm looking at this, I'm gonna go to my table. Okay, so if it isn't already starting at 0, we want it to start at 0. And if you look here, if I just went by ones, okay, if I just went by ones, this would only take me to 6,770. Keep in mind that we're going to want to see when the investment is worth 10,000, so I'm going to want to go more than that. Okay, so you can decide what you want to go by, okay, whether that be 2s, 3s, 4s, 5s. I decided to see what happened over a bigger span of time, so I did my change in the table by 5s. So when you do have something that's more spread out, that's going to be easier for you to see what's happening in your graph. So I just did 0, 5, 10, 15, 20, 25. Again, when you're doing this on your own, you might have something slightly different, and that's okay. But if you do see that the investment's going to be worth $10,000, you need to at least include that in your graph. And your 0, you should already know right away, because 0 is the initial value, so that's going to be the 5,000. And then at 5, it's 6,770. You can just go ahead and round these. The change isn't going to matter when you're doing this by hand, because we can only estimate so much when we're doing this by hand. Okay? So this is going to give me a nice picture about what my graph is doing. We are still doing exponential functions, so they're going to have that curve in there. And then if I'm going from 0 to 25, I just want to space this out so that I can get the 0 through 25 on there. So I might go 5, 10, 15, 20, 25. So technically, every tick mark would be 2.5. That's fine. If you want to put yours closer together, that is fine too. So in this case, our x is going to be the time. This is in years. Yep. And then your y value, this is about investments. So that's going to be the amount in the account. Okay, so that's the account balance in dollars. So if I want to get up to 22,000, let's see if I went by 2s, if that would work. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Yeah, that would be like right up there. So 20,000, 2,000, 4, 6, 8,000, 10, 12. Okay, and again, I just decided to go by 2,000 to fit it on here. When you're doing this, you'll have graph paper, so you can decide what you want to go by. If you wanted to make 22 tick marks, you could. Okay, so you have that authority to determine what you'd like to go by. Okay, so at 0, we're at 5,000. So if this is 4,000, 5,000 is going to be right in the middle. At 5, I'm almost to 7,000, so maybe I'd put that a little bit below the line. Again, a lot of these are going to be estimations here. At 15, I'm at 12,414. So I'm almost to 17,000 there, and at 25, I'm a little bit above 22,000, so it'd probably be like right there. Okay, and you are connecting this with a curve. This is just a slight curve here. Okay, and then your arrow does go on this side. Okay, so it said to write in graph, and we did that, and then it says determine how many years it will take her investment to be worth 10,000. So how could I find that? So your table is going to be a really good way to narrow that down, right? So if I'm looking at my table, I know it's going to be worth 10,000 in between what 2 years? Yeah, so somewhere between 10 and 15. So I want to narrow that down. How could I use my graph to do that? Okay, yeah, so at 10,000, right, can I just make a line at my 10,000? Okay, so if y equals 10,000, I can find where it intersects. Okay, so mine intersects here. This is the intersection. And then I'm just going to find where that is. Now remember, I went by 2.5, so this is like 12.5 here. So this looks like it's somewhere around 11 years. Remember that this is going to be an estimate, okay? There's no way I'm going to get an exact 9,168 on my graph that I did. So we're going to use our calculator to help us find that exact value using our intersection feature. So if you go back to y equals, you're going to put in that y equals 10,000. And then do you guys remember where your intersection feature is? Yep, second, and then your calc. So it's second, it's above the trace button. And then you go to 5, which is the intersect. And then it's just gonna, oh, sorry. I already have my window set. So you guys have your standard window, right? So when you hit graph, what happens? There's nothing there because look, we've already made our graph here. Let's just use this as our scale. So when you go to your window, our x value and our y value both started at 0. So our min should be 0. And then mine went up to 25, and I went by 5s. So I can put that in exactly like that. And then my min for y is 0. Okay, I went up to 22,000, which is fine, because look, you can see that your intersection is going to be here, but you are going to want some space to be able to find it. And then I went by 2,000 each time, so I can just put that in as my scale. And then I'll have a graph that mirrors what I graphed. And then I can do second calc, intersect, and then you just try to get right on the intersect and pay attention to what it's asking you. So first curve, yep, that's where I think it is. Second curve, yep, that's where I think it is. Guess? Sure, I'll guess that. So this one you really are pressing enter 3 times once you find it. And then it should give you the x value. So it says x is 11.4 when your y value is 10,000. Okay, so that means about how many years will it take her investment to be worth 10,000, and we're gonna use the 11.4 years. We're gonna use the decimal from our calculator. Now that makes me happy because on mine I was close to the 11.4. Okay, so your graph should be somewhere between 11 and 12, depending on how you made that. Okay. Okay, and then how did you guys do at finding the intersection?
Pretty good.
All right, then I want you guys to try example 2. I want you guys to write an exponential function. Yep, so when you're writing an exponential function, keep in mind, is it growth or is it decay there? Okay, so I want you to try. And what was the key word that let you knew it was decay? Yep, so if it's dropping, it's going to be decay. So that's how you know it's the 1 minus your R value. And then if it's 3%, your R is going to be 0.03. Or 0.03 is fine as well. Again, you're moving that twice. And then anytime it says initial, you know that's going to be your A value. So 15,500. And you're not going to leave it as this. So your final model is going to be the 0.97. Okay, and then this is your decay model. So when you guys plug this in, and you looked at your values for X, you already had it going by 5s. How did that look? Okay, so let's do that again. Okay, and then like I said, if they don't tell you what to go by, you can choose. So with something like this, when you plug this in and you're looking at your values, okay, if you have a bunch of them that are close together, that's a good indicator that you might want to go by something other than ones. Okay, so if you were to plug this in and instead of the 5s, it was by 1s. If you look here, right, this would only be dropping like 2,000 if you went by the 1s. Eventually, we're going to have to use the graph to predict when the population will drop below 8,000 people. And if you went by 1s, that wouldn't happen. Okay, the 8,000 people is not going to happen until much later on. So those are different things that you want to look out for when you're determining what your table should be. And then just double check to make sure you plugged everything in right. The first time I did this, this dropped from like 15,000 to 4,000. Okay, if it's just a decrease of 3% per year, it should not be dropping by that much. So those are just little things you can do to make sure you have the correct values. And again, when there's a decimal with numbers that are this high, you can just round up or round down because it's not going to make a difference in your graph. Okay, so again, I can go 5, 10, 15, 20, 25, and again, this is your time in years. Okay, and then I'm trying to, I have to get up to 15,500. If I went by 1s, I wouldn't be able to get up there, so I'm going to go by 2s again. So 2,000, 4,000, 6,000, 8,000, 10, 12, 14, 16, and I really don't need the ones above there because it is decreasing. Okay, so at 0, I'm at 15,500. So here's halfway, and then I'm going to say that's about halfway of the halfway. So as you guys are going through and estimating, just think about, okay, here's my 10,000, a little bit more is 11. 15 is going to be a little bit under 10. 20 is at 84. 25 is at 72.38. This is 6, so 72. This one is, I don't like that. This one is decreasing by 3%, so it's going to be a slighter decrease. I don't like the way that looks, so I'm going to do it again. Okay, so it is decreasing over time. Alright, and then it says use the graph to predict when the population will drop below 8,000 people. So again, we're going to do the y equals, and we're going to find the intersection. And we're going to use our graphing calculator to do that. Again, you can also look at your table to estimate. So I know that at 20 years, it's going to be 8,429. So whatever answer I get, it should be above the number 20. Okay? And then if I estimate with my graph, mine's about right here, so remember this is 22.5, so mine looks like it's a less than 22.5. So I'm going to be looking for that on my graph. Okay, how did the intersection feature go doing this without me? Alright, what did we get? Great. And again, that same window will work. Okay, and then you just have to use your left or right. And once you find it on the first curve, you can just press enter, enter, enter. Okay, so if x is 21.7, when y is 8,000, it says when will it drop below? So you're just going to say after 21.7 years. Because it's saying when will it drop below, not when will it be 8,000. If it was when will it be 8,000, it would be approximately 21.7 years. Alright, any questions for me on that? Alright, then let's learn the compound interest formula. So the compound interest formula either has A equals, or sometimes you'll see A of t. It really just depends. And then you have P times 1 plus R over N to the power of N times T. Yeah, there's a lot more in that one. so the A of t, or like I said, sometimes it's just A, that is the amount after t years. Okay, the P stands for the principal. That's the initial amount. And then, so this is P times 1 plus R over N to the power of N times T. And then your R is still the same, so your R is the rate as a decimal. So it's always going to be the rate as a decimal. The T is still the time, but now there's a new variable, okay, the variable of N. Okay, N is the number of times per year it's compounded. It being the amount of money in the account. So N is the number of times per year it's compounded. Okay, so we're going to go over some new terms to figure out how many times per year it's compounded. Okay, so Seiko deposits $3,500 into an account, and then we have to find the balance after 8 years for each of these scenarios. And it says to round to the nearest cent. Really, that should be what you always do with money. Okay, so you're always rounding to the nearest cent, which is the nearest hundredths place. Okay, so we have an account that pays 5.8% annual interest compounded monthly. So to determine the value for N, you just have to determine how many times it happens per year. So monthly, how many months are in the year? 12. If we look at the next one, we have a new percent, and then this says it's compounded quarterly. How many quarters are there in a year? 4. And then if it says like annually is how many times a year? Once. Semi-annually? Twice, like a semester. Yep. Okay, so for part A, we have to find the value at 5.8%, which means your rate is going to be 0.058. So you always move it 1, 2 to the left. Okay, and then your A value is the 3,500, or sorry, your P. It's the P now, the principal. And then 8 years is going to be your value for T. Okay, so like I said, sometimes you'll see A of T, sometimes you'll just see A. So your amount is equal to what you originally invested, the 3,500, 1 plus 0.058 divided by, in this case our N was 12 because it was monthly, and then it's to the power of N times T. So that will be 12 times 8. Yeah, depending on your calculator, you just have to be careful about how you enter this into your calculator. Okay? Or should we do this without our calculators?
We should do it with our calculator.
I'm just joshing. You will always have your calculator for these. So some of your calculators will do this even if you just put the divide. Some of you are going to have to put the 0.058 divided by 12 in parentheses. I always just do it to be safe. And then close that parenthesis and then to the power of. Now, if your calculator does the power like this, you can just put 12 times 8. But if your calculator does the caret, then you have to put this in parentheses. So if your calculator does the caret in parentheses, you will do 12 times 8. close the parentheses, then you press enter. Okay, and then you will know if you put it incorrectly if your final answer for this is $5,560.26. Oh, okay. So the quarterly means that it's only going to be compounded 4 times per year instead of the 12. So now in part B. So in part B, the account pays, it gives you 0.75%. Now, when there's a decimal given in the percent, sometimes this messes people up. So I just want to remind you again, you are going to do 1, 2, and then you put your 0 in as your placeholder. So your rate is 0.0075. Okay, and now if it's compounded quarterly, you're going to plug in 4 for n. So the things that are staying the same are the 3,500, which is the principal, and then the amount of time, which is 8 years. So it's going to be the 3,500, 1 plus, and then you have R over N, which is 4, to the power of 4 times T, which is 8. So if you have a, bless you, if you have a calculator that does the, that you need to put the parentheses in, if you just do that part in your head, because you know it's 32, okay, that will be a little bit different. And if you want, here's a little trick for some of your graphing calculators that you probably already know, but if you enter it here, if you just put that, because the 3,500 is the same, you can just go in and insert a 0, 7, 5, oops, and then just delete it. So I have 0.0075, and then it's divided by 4, so I'm going to delete that. And then now it's for, yeah, you can just delete. Yeah, so you can do that.
When you were doing like the R squared stuff, it was like the whole paper long.
Oh.
Just going up and I had to read it up. So fast.
Hey, guess what? We get to do the R stuff again in chapter 7. This week, actually.
You're lying.
I'm not lying. Would I do that?
I hope.
I hope so. Okay, so $3,716.22. All right, and then, so like I said, on your homework, there's going to be 2 different parts. Okay, the first part is from 7.1, and I'm going to show you this on the calendar, but in 7.1, there's 3 questions, and those are the only 3 that you have to graph, okay?